5, please. Yeah. So, here, if it asks for the moment the item is released, that's the y-intercept, correct? We talked about that. The moment something is released, time is 0. That's a y-intercept. If it asks for the height at time 0, it's asking for the y-intercept. If it asks for the maximum height, it's asking for the y as the maximum minimum. If it asks the time to reach maximum height, it's asking for the x as the maximum minimum. If it asks for when the object hits the ground, it's asking for the x-intercept. If it gives you a specific y and asks you to find the specific x, you put it into y2 and find out where the intercept. If it gives you a specific x and asks for a specific y, you can go second trace value and put the x in for that, or substitute in for the x of the equation. Remember, domain and range are restricted in word problems as you cannot have negative time or negative length. You have to watch yourself, right? You can't go y-er, x-er. First off, it's not even x usually, and it's not often y, so you can't use those letters. Okay? So let's look at this first question. I want you guys to type this one in. It's going to go, the growth of a tree can be modeled by h of t. H of t is my y, so I always help myself out there. I go h of t equals y equals what? What is the, equals y, and then what's the units? Help myself out. What are the units for y? For h of t? Pardon? Meters. It says A represents the height in meters. So I know anything that's in meters is y is height, correct? Then t is in the place of x, and what's its units? What's t's units? Years. So height is in meters, t is time is in years. You guys, please pay attention. It will always tell you the units, okay? It has to always tell you what the letters represent. So it's the growth of a tree. It's represented by this equation. What is this equation? What type of equation is that? Linear degree 1, right? Because the exponent on here is a 1. It's degree 1. It's linear. It's going to make a line, okay? So everyone go and type that into their calculators, that equation. Then we're going to talk about windows again, like we did yesterday. Now, if we don't know what to set our window to, we will use our question, especially if it's a multiple choice, to help ourselves out. So, our equation is 2.3 x t theta n, x that we use, minus 0.45. We agree? Okay, I'm going to tell you how I use the question personally to help myself out with windows. Okay, so let's look. I told you already the y-intercept is helpful. The y-intercept is negative 0.45. Wait a second, the y-intercept is negative. It's a tree. Why is the y-intercept negative when time is 0? Why is the height negative? How does that make any sense? It starts in the ground. It's a seed in the ground, correct? Trees, it's on a pot on the earth, like above ground, okay? So that makes sense. Now, is it going to get lower than that? Can it get lower than that? Think it's a tree going in the ground, but a seed. The seed sprouts, grows, tree hopefully grows upwards, right? We hope it doesn't grow into the dirt. Its roots will, but the tree will grow upwards, correct? So it should be bigger, okay? So I know that my height, so I go to my window, I know my y minimum could be negative 1, let's say. It can't be any lower than negative 0.45. But if I want to actually, I'm going to go negative 0.45. People don't pull. Oops. Okay. Now the y max, this tree could grow on forever, correct? Let's just see what we absolutely need. So we'll come back. Here it says, to the nearest tenth of a year, approximately how long will it take to grow to be 32 meters tall? So what if I make my y max be 20? I'm in trouble, correct? Because what do I need my y max to at least be for this question? 32. So we can read. We should read. We have to read the whole thing. It is helpful to us. So they want us to know to the nearest tenth of a year, so that's 1 decimal place. I'm going to write that to help myself out. I write this to remind myself, 1 decimal place. Approximately how long, that's time, will it take to grow to be 32 meters tall? So that's an h of t. It's kind of yes? So I go to my window, and I make my y max be bigger than 32. Maybe I make it be 40. Right? Do we agree? We just know it has to be bigger than 32 or I won't be able to calculate this. Okay, let's go back. Now our x's, we don't know exactly what to do, but we know that our time has to start at what? 0. Can't have negative time, correct? Now, we had our time has to start at 0. How big of a time should we make? 10, 20, 30, 40? We could choose, correct? But if I look, this is a multiple choice question. Do you see the answers? I have 13.7 years, 14.1 years, 73.2 years, 74.2 years, or 74.1. What do I know? It's going to have to be smaller than 74.1 years. There's no other options, correct? Now, what if it's 14.1? Cool. It still exists in my window, right? What if it's 73.2? It still exists in my window. So I'm going to go to my window. I'm going to make my x minimum be 0 because of time. And I'm going to make my x max be 75. Because then it covers every single answer that's in the multiple choice. You see what I'm saying? You can use those answers to help you out. So then we press graph. I can see a line. Cool. Great. Awesome. Now I need to actually figure out how the heck to do what. So I got myself a window that I hope will work. I need to know when the height is 32. So did they give me y or did they give me x? So I go height, h of t is equal to y, and it's in meters. Anything in meters means they gave me y. We agree? They gave me y, they want x. Where do I put y if they give me y? Yeah?
Into the y equals.
Into the y equals 4y2. Yes. Make sure you don't clear out your y1 because you've got rid of your original equation. You're going to retype it back in. That would suck. Not the end of the world. But go to y2 and I put 32. Now, if I were you and you were me, I have different colors, so I'm good. But if your calculator doesn't have different colors, I always move to the left and I make my second equation thick. Remember, this is why I make my second equation thick. So when it drew, I'm going to repeat. Watching. Everyone put your pencil calculator down. If I go 32 and I press graph, it will draw the blue, then it will draw the red. Right? It always draws them in order. Okay? And I have blue and red. So it's very easy to tell that the red's the second equation. We agree? But if I quit it now and I press graph, it just draws them at the same time. It will draw them in order once, and then after that they're drawn. So what I always do if I have the colored ones, cool, I have 2 colors. It's easy. If I don't have the colored ones, I go over to that slash line. So go to your y2. Whenever I have 2 equations, I go over to that slash line over here, and I hit enter once, and then press graph. And then the thicker line will always be the second one, because we don't have colors. Do you know what I mean? So hit enter there, and you get that thicker line, and now you'll have this thin line, and then this one will be a thick one. And you'll know that when I go and get out of here and I go back in, oh, the thick line, or for me the red line, is always the second, and it doesn't matter that they're drawn right. Does that make sense? So it is better to make a differential between the two so that you don't have to retype it back in to get it to draw in order. Okay. So, what do we do now to find our answer? Second trace intersect. Second trace number 5. Now, life lesson. Whew. Crystal in high school would just press buttons in hopes that the little blinking thing would come back. I'd be like, please, the blinking thing is not here anymore. Everyone paying attention, put your calculators down, because I think 90% of you were in the same boat as Crystal was in high school, who's me. I'd be like, there's no blinking thing. I'm going to press buttons until hopefully the blinky thing comes back. That was a bad decision in my world. I hope you're not in the same world, but if you are, you're going to learn from my mistakes that I didn't know until I got way out of high school. Down here tells you where the blinker thing is. On the bottom, the numbers tell you where the blinker is currently. Where is the blinker currently on mine? 36 and 83. So is it down here off the screen, or is it up top off the screen? It's up top. Top. It is up top off the screen. There's two things we could do to fix it. We can arrow left, and if you look, look, it's starting to, I just did the other thing. You can arrow left, and it'll show you over 30, 64, 62, 59, 58, 53, 50, 47. Oh, the blinker's back. We could do that. Or what did I tell you? How can we quickly get on the red line that I just keep popping onto? You could just arrow down, right? And get onto the other line. But the blinker tells you where it is, okay? This is what I love about the color calculators. Do you see that it's blue right now when it's on the blue one? It's red when it's on the red one. So great. Okay, enter, enter, enter. And I get 14.1. Which is B. Do we agree? Okay. Now what I want is there only one question that can come from this question? From this option, representation, this original information? No, tons of different questions can come from it. So here are alternate questions for this situation. A and B. I want you to try and get me the answers. Go. When it says the original height of the tree, what does that immediately tell you? Yeah, so x, which is equal to t, is equal to 0 years, correct? Now we can do that one of two ways. If it just says what was the original height of the tree, does it say algebraically determined? Does it say that up there? No, it says what is the height of the tree. So in that case, we can go second trace value 0, enter, and it's negative 0.45, which we already discussed. Meters, right? We could have also just taken it from our equation because it's the y-intercept. If it says algebraically determined, and I want you guys all to see this and write it down. If it says algebraically determined, you must show algebra. So that means we want when t equals 0 years, we take our equation. Our equation is h of t equals 2.3t minus 0.45, and we're finding h of 0. So we plug in h of 0 like that because 0 is going in for t. 2.3 times 0 minus 0.45, and we get negative 0.45 meters. Meters. So do you see that? If it says algebraically determine, you have to use algebra to determine, right? If you go to your calculator, you just get an answer. How much marks do you think you're getting? 0. Yeah. So algebraically determined means algebra. Now you're going to say the original height of the tree was negative 0.5 meters. Okay, the next one says determine the height of the tree at 23 years. Does it say algebraically determined? No. Can I just find an answer and write it, and you can put it in a sentence, and then that's good? Ish. You need to actually show what the heck you're finding if you're using your calculator, right? So if I want determine the height, so I want h of t, I'm going to show some work here, h of t, when t equals 23 years. I have to show them that I'm actually know what the heck I'm doing, right? I can't just go like 4.5 meters. Done. And there's no work whatsoever to be found on the page, right? So did I give you height or did I give you time? Did I give you y or did I give you x? X. So if we use our calculator, we can go second trace. I want to change, don't change your window. I just want to show you. What if I made my window be 20? Just paying attention, don't change your window. So say I made my window be 20, right? If I go second trace value, 23, enter, it gets mad at me. Why would it get mad at me?
Your window is not big enough.
My window stops at 20. My window stops at 20, and they want 23. They can't calculate what it can't see. So if you get like invalid, often it's your x max isn't big enough. So I'm gonna, so do not put a thumbs in. Oh my gosh. I'm gonna put it back to 75 where it was. Second trace value, 23, enter, and I get 52.45. Meters. Now, once again, shh. What if it said algebraically determine? Can I use my calculator like I did if it said algebraically determine? No, I have to use my formula. My formula is h of t equals 2.3t minus 0.45. So this would be in the written response. I'm going to go h of 23, and then I plug that in. 2.3 times 23 minus 0.45. When I plug that in, I get 52.45 meters. So the height of the tree in 23 years was 52.45 meters. Okay. Now we're going to flip over. So that was what type of equation? Linear, degree 1. Flip over. What do we have behind now? Quadratic. So let's decipher out this question. This is one context, and then there's alternate questions to go with that context. Everyone paying attention? Put your calculators down. We're going to discuss this. We're going to pay attention, because what's going to happen is you guys are going to try and type it in while I'm talking. So please stop touching your calculator. All right. A science class is investigation trajectories. I should say investigating trajectories by launching balls with a catapult. Catapult to do this, right? Just like tossing the ball yesterday. Okay? I tossed a worm, but that's fine. Or a caterpillar, I think it was. The pathway of one particular ball can be modeled by this quadratic function. Quadratic functions are degree what function? 2. What's the largest exponent? 2, and that's the degree. So cubics, the largest exponent is a 3, so it's degree 3. Okay? So, where h is the height of the ball above the ground in meters, and t is the time elapsed. So h is the height of the ball above the ground in meters. So I help myself out. I say h equals y equals height. And then I go meters. To try and help myself out, written in American, that's fine. Okay, and then t is the time elapsed since launch in seconds. So t will be the same as my x in my calculator, which is time elapsed since launch. And that is in seconds. All right. So we need to be able to graph this and see it. If you look, there are hints to your domain or range in this one. Look, the domain's between 0 and 0.7 or 0 and 1.5. So I'm going to make my x min be 0 and my x max be bigger than 1.5. Right? That would cover both these domains. We agree? So I could do like 1.6. Then my range is either between 0 and 3 or 0 and 0.5. So if I go like 0 and 4, it should cover the domain, right? When I'm multiple choice, they should be easier than numeric response because you have hints. Okay? So you're going to try 2 and then A, B, C, D, E, F, G. There's so many. Go. Okay. Then I said I would make my window be based off of these and off of these because it kind of gave me little hints. Correct? So I'm going to go to my window and I'm going to make my X-min window. Window. Come on. I love technology. Window. If my X-min be 0, my X-max be 1.5. Let's say 1.6, sure. And then my Y-min be 0 and my Y-max be 3.1, let's say. Graph. Aha. So, just solely knowing what these should be, I can tell you what my domain and range are. The biggest ones. It really fits the biggest data, right? If not, we can check it out. How can we do this? Remember I told you we can draw stuff, right? So, to help myself out, let's go. I have that. I can do a quick sketch of that, right? This is my quick sketch. And then I can get info from that. So what's the y-intercept, guys? 0.5. Is that helpful for this situation? No, don't care. So this is 0 and 0.5. 0 seconds and 0.5 meters. That's this coordinate. I'm going to fill in all the coordinates. Your phone should not be out, and you should be paying attention. Then I'm going to get the maximum. I'm going to go second trace max, which is 4. Left bound, right bound. And I have 0.71 and 3. Do I just go 0.71, or what did I tell you to do last time? Yeah, just keep going, right? You have to write all of them because we don't want to round until the end. So I said like 4 decimal places, right? They're not going to ask for anything higher than that. So 0.7143. Now I forget, 7143? 7143 seconds and 43 seconds, okay. Comma, 3 meters. I'm just putting down important data, correct, off of here? And then my x-intercept, I said you can do it one of 2 ways. You can go second trace number 2. I love this board. Second trace number 2, and then you can go left bound above it, right bound below it. Or I said you could make your y2 be 0, and then find out where they intersect. That was another option. Come on. Oh my gosh, this is insane. What the heck? Enter, enter, enter. So 1.4967. And 0 meters. Right? Yeah. Sure. So, what is our domain between 0 and what? 1.5. Now I'm at a 50-50, even if the rest of the stuff fell out of my head. Right? What's my range at? 0 to 3. Oh, see. Right? Okay. Now here it says, determine the height when the moment the ball was released. So we want height. Ball was released is a fancy way of saying time equals what? 0 seconds. So what is my height at 0 seconds? What was my height at 0 seconds? 0.5. We can find it here, or we can find it here, because that's my y-intercept. We agree? So, the ball was 0.5 meters high at the moment of release, at the moment the ball was released. Okay, determine the maximum height. So I go to the maximum. Which one of those is height? 0.7143 seconds or 3 meters? 3 meters. It's a lot easier to tell which one's height if you put units on those numbers, correct? Because you're not going to say, oh, the maximum height of the ball was 0.7143 seconds. You'd be like, wait a second, seconds isn't height. Something shady. You know what I mean? So if you put units on your coordinates that you draw here, you will stop yourself. So the maximum height of the ball is 3 meters. Determine the time the ball reached the maximum height. Which one is that going to be? The x. So the ball reached the maximum height. Now, if on a test I don't give you a rounding rule, then you can round to whatever you want and I can't deduct marks. On a diploma, that's if I just missed for forgetting to put a rounding rule. On a diploma, they will always have a rounding rule. Look for it. On a test, I should always have a rounding rule. If I miss something, then maybe I don't, but then I can't deduct you. So always look for rounding. So this one doesn't have anything, but I'm going to say to the nearest tenth. What would it be to the nearest tenth? 0.7 seconds. Determine the time the ball hit the ground. Which one of these is ball hitting ground? 1.5. So if I say nearest 10, the ball hit the ground at 1.5 seconds. And this one says determine the height. The ball at 0.5 seconds. So that's t, which equals x, which equals 0.5 seconds. Correct? So we can either plug it into the t's of our equation, or we can go second trace value. What was it again? Which is 2.775. So if I go nearest tenth, it would be 2.8. The ball hits a height of 2.8 meters. Meters, right? Yeah. Determine the second time. Second time the ball reaches a height of 1.2. So once again, h equals y equals 1.2. So we go to our y2, and we do 1.2 math. Second time. So yes, this one it does. I don't really care. I want that one. Second trace 5. Second trace 5. As long as I'm closer to this one, it should pick it up. Enter, enter, enter. Nearest tenth, 1.3. At 1.3 seconds, the ball reaches a height of 1.2 meters for the second time. And then this one wants you to determine the time the ball was above. So the time the ball was above a height of 0.75. So that's your y2, and it wants to be above. So let's watch it out. So we go, everyone paying attention? Oh, come on. 0.75. There are 2 times where this crosses, correct? We want the time where they're above. So if I take this time, this is the time it takes to reach, the whole time it takes to reach here, and I take off this time, then I'll have the time where it's above. You know what I'm saying? You take the 2 times and subtract them. So we're going to go second trace 5. Watch this. I'm going to show you a trick. So we go enter, 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 and I get this new x. Do you see it? Does everyone see it? That's my new x for this question. What I can do now is I can go second quit, x, enter, and it pops it up onto my screen. So there's that first intersection, right? Now I get my second intersection. Second trace, intersect. Actually, I think this computer, I don't know what's faster. This is painful. Da, 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 da. I feel like it needs background music. Oh my gosh, my finger hurts. My arm hurts. I hurt. Okay. New x. We agree? I got a new x, the new x intersection. I can go second quit. I can go x enter and I'll pull that one up. And then what do I just need to do? Subtract them. If you have the calculator where your arrow goes up, you're welcome, because it's way faster. Now you would show your work on a test, correct? You would show your work. You'd write down these numbers. So to the nearest hundredth, it would be 1.36. So the ball was above a height of 0.75 meters at 1.36 seconds. Okay, we're going to flip over. What's on our next page? What could you guess? You were a guesser. Cubic, which is a degree 3. Shocking. We did a linear, quadratic, and a cubic, which this unit is on linear, quadratic, and cubic. I know. It's crazy, right? All right. 3, 4, 5. Go. I picked this one specifically because it's not the nicest looking function. It is nice until you actually have to zoom in for what it says. So it says, a scientist studying a new antibiotic drug carefully monitors the weight of a rat over a number of weeks. The weight of the rat during the course of the 6-week study can be modeled by this equation. It's cubic. It has a y-intercept at 450, correct? So if your window is from 0 to 10, you ain't seeing the rat's weight, right? Now, where y is the weight of the rat in grams, from 0 to 7 is what they're limiting us in time in weeks. So they're studying this rat for 7 weeks. And people want like its weight to go aggressive. Like, do you want the fattest rat ever? Like the rat to like lose a ton of weight? Because like you guys want to be able to go from like 450 to 1,000. Like that's a really fat rat in a really fat amount in a short amount of time. Okay, so let's realize where a rat could be. So which of the following characteristics of weight function should be analyzed in order to determine the weight of the rat when the beginning of the study began? So when the study began, what is that? Is it the y-intercept or x-intercept? Y, because weight is y, correct? Okay, everyone's good at that. Then we need to get the graph to show up, and that's where it went downhill a little bit. That's okay. I expect it to. So we have 0.38x cubed. I just pushed clear. X cubed minus 3.81 x squared. Now remember, when you're doing math and you're learning something for the first time, do I just expect that you all have complete knowledge and will do it perfectly? Wouldn't that be great? That's not how you learn math. I expect there will be some struggle, okay? Like this. I put it in the exponent. Here's my struggle. Ah! See, I just wanted to show you that struggle can happen to a teacher too. Yeah, that's what I'm showing you. Why? 3. That is what I'm doing. No, I'm just stupid. It's fine. 3.81x. Do you know how many times I've had the calculators that the exponent popped up? Do you know how many of those I own? Like none, because they get stolen. So I have all the lowercase ones. I never have to worry about this whole popping into the exponent. It'll keep going. Garbage, where you have to arrow down. Except for this one, because people can't steal it off the computer. All right, squared. Plus 10.92x plus 450.02. Graph skis. Okay. Wow, what an amazing graph. This window is awesome. Could it be better? No. This is amazing. So then people are like, Zoom 6, which I told you to. Ooh, this is great. I love this graph. Okay, so it gave us a restricted domain between 0 and 7. It literally says that. It has between 0 and 7. So that's the first thing I'm going to do. I'm going to go 0. I'm going to go 7. Then I know this rat starts off at 450.02, correct? So I'm going to go 400. Cool. A little bit below the rat's weight, a little bit above the rat's weight, 600, and I'm going to press graph. Now this is a cubic function. It's just a super zoomed in cubic function, correct? This would come down here. This will come up here if I didn't zoom in to it. Yes? Alright, so there's my cubic. It wants to know how long did the rat's weight first reach 459 grams. After how long? I was like, that made no sense. Forgot the word after. It's a real bummer if you don't read the whole thing. After how long did the rat's weight reach 459 grams? So that's my y. 459. Boom. Second, trace 5. I'm going to go with the first one. Let's go. Let's go. Let's go. Let's go. Let's go. Let's go. Look at this fluctuating rat weight. Look at it. So I'm getting fatter, getting a little weaker, getting a little fatter. You know? Really ended strong at the end. Got themselves, they're not fat, sorry. Bulked up at the end. What word am I using? Silly me. Bulked. That is a bulked up rat working out. They're probably lifting some seeds or something. Rat bait. That would be a dead rat. So no, seeds. It's like, I can now lift walnuts. Like super strong, bulked up rat. Okay. 1.44, which falls between 1 and 1.5. We agree? Cool. And then, if you found a different one, it's because you didn't find the first intersection point. There's a few. Okay, after 7 weeks, the researchers should expect the rat's weight to be what? Bulked up. That's our answer. But we have to give them a number. But I really want to write bulked. Bulked up. Okay, round your solution to the nearest hundredth of a gram. So, we can either fill 7 if it was actually algebraically into the equation, or, let me take this one out, second trace value 7. 470.11. And that, my friends, is a bulked up rat. Okay, this is your assignment that is, you have to work on tonight. So everyone come grab one. Not so quickly.